I'm Rose Edmondson and I'm a teacher at Fairlington Park High School in Rochdale. I've been teaching for almost 20 years now, and probably the most interesting and enjoyable experiences for me in teaching happen to be the practical side of biology, and in particular teaching children about how to use a microscope. There's always real wow moments when we do that. So this video is aiming to address some of the tricky aspects of teaching the topic of electricity to Year 4 in particular, but also beyond. Misconceptions will be explored, and by the end of the video, you should be more confident to teach the topic to your class, as well as being more comfortable in answering any difficult questions that might arise. Accompanying this video is going to be a troubleshooting guide, which is just a short sheet that's going to aid as some reference point for you to allow you just to review some of the key points, the knowledge, suggested activities, and further reading. So you can see on this slide, that's what these videos are going to aim to do. So although this video is aimed primarily to be used by Year 4 teachers as part of the preparation for teaching electricity as a new topic, it might also be suitable for you to review before you teach Year 6 the electricity topic as well. The video is going to discuss misconceptions and misunderstandings which both teachers and children might have, and just looking at ways that we can unpick and start to address these. The videos can be used at a convenient time for you, so they're just designed to boost your knowledge and understanding. All the videos in this short series will be less than 15 minutes long, so hopefully that's going to deliver a short, effective boost to teaching prior to you teaching what is seen as an abstract topic. The research tells us that subject knowledge is a key focus when Ofsted visits schools, and although curriculum knowledge is generally good, science-specific knowledge and understanding can sometimes include gaps and can lead to misconceptions. It's also been noted that sometimes difficult questions are ignored or avoided, and misunderstandings aren't challenged or explored further. Quite often, these misconceptions arise because children and adults arrive in school with their own experiences of science from outside of the school, which obviously they bring into the classroom. Both children and adults will have firm beliefs and explanations which may or may not be correct. Research suggests that providing children and teachers with time to explore and challenge these misconceptions can be particularly effective. Using a running commentary alongside some of these activities that we'll talk through today can also help to change and clarify thinking, which is basically what these videos aim to do. So, looking and sticking with that, what would you think, and what your initial thoughts if a child asked you, is electricity used up in a light bulb? How might you approach answering that question and exploring that question together in class? Would you be confident to explain, or would you worry about giving misinformation? So just before we sort of look at some of the resources that can help you in the classroom, some of the demonstrations you might want to look at, or the activities that children might want to explore, this slide will be will be repeated in the reference guide, but I have found the best evidence science teaching resources to be quite effective. Using the Plan knowledge matrices as well can help just to pinpoint certain misconceptions, and also the PSTT have got a selection of PDFs, so some of the activities have been extracted from that today, and they're a good starting point to prepare yourself in advance for a question like that. So, is electricity used in a light bulb? We'll have a look as well at what the children actually need to know for this topic, because this might be a question that comes up in Year 6. It might also be a question that comes up in Year 4. So you can see there, and I'll just let you read that, what they need to know and how and where the progression is. So ensuring children then in Year 4 have a clear understanding of circuits will really help them in their science learning and strengthen their next steps when they visit electricity again in Year 6. However, there are lots of opportunities to embed misconceptions if we're not careful. even more so because of the fact that circuits work because of actually what's happening inside the wires. And of course, children can't see those things. So although what electricity does is quite easy to see, we can see the effects, to really understand why and how and what's going on is much more tricky to explain. So there are lots of misconceptions which can appear prior, during, or after this topic has been taught. So if I look at some of those with you, if I look at those in a list now, can you identify the misconception from this list that might need addressing in a child's question from earlier? So you've read through those. The misconception that really needs addressing is that bottom one, that idea that electricity is possibly being thought of as like a fuel, and it's actually being used up as the current flows through the components. So you can understand where that misconception can arise, really, particularly if a battery is providing the energy, which quite often it is in primary school setting, because the language that you use at home would be, well, you need to replace these batteries because they've been used up. They're now used completely. So it's quite often that abstract nature of energy as well that isn't really explored at primary that can cause issues. And the idea that energy is being passed around a circuit, and it's that flow of current as well that can pose issues for children, because they can't actually see what's going on at the particle level. And that might be something that you do decide to include in your teaching, and it might be something that you decide to hold back on. But throughout this topic, language is crucial, and there are suggestions for words to avoid, but also there are key terms as well that I think needs to be emphasized at year 4 and also at year 6. So again, these are repeated, these key vocabulary, or this key vocabulary is repeated in the reference guide. But I just thought I'd flag them here. Unfortunately, the language, some of these words are used differently in our everyday language, and that obviously doesn't help. So explicitly teaching these concepts and these keywords will really, really help embed a strong understanding of what's happening in a circuit. And there are certain words as well that I think need to be avoided and challenged throughout this topic. And I just suggested some of those here. It's quite easy to slip into mistaking the terms, particularly at the bottom there, with the use of the word electricity, voltage, and current, but actually they're distinct, they're separate things. And explicitly getting that message across to children will really, really help, I think. So our everyday language then sort of comes into the classroom, and sometimes the language that we learn in the classroom can be then taken back home. So that isn't particularly helpful. But I'm going to now take you through some of the examples, I hope, of some of the activities you can try to help unpick some of the misconceptions around language and misunderstandings around electricity. So one of my favorite ways to do that, and I do apologize for the picture here, it's not particularly clear, but one of the most effective ways to do that is to use something called an energy stick. And if you don't have one of these are really easy to pick up from places such as Amazon. There's probably other places where you can get these as well. It's basically a stick that is made from plastic, but the ends are made from metal, so they are conductors. And inside there is a wire that will light, and it will also make a loud noise. So this energy stick, it's probably priced around £7, so it's not particularly costly. And this can be used to demonstrate various aspects of electricity. So one of the most effective ways of doing this is actually setting up the children so that they arrange themselves as they would in the pattern of, or the structure of a circuit, including wires. So you're setting them up to model what's going on in a circuit using this. So they can stand in a row, and they can then turn them, gather one end to the next. And as they do that, one person can hold one end of the energy stick, and then another person will hold the other end. So what that then gives them is once they both are in contact, they've got that complete circuit. And obviously once that's broken, or actually if it's broken anywhere, so if one person detaches themselves from that ring of people, that will then stop any flow of current, and so that electricity cannot, or that flow of electrons, or that flow of charge, if that's the language you want to use, that's being prevented. So that's an incomplete circuit. So that's quite a nice demo. You can also use this energy stick, and there are videos on YouTube as well if you want to look at it in a bit more detail, but they can be used alongside some conductors and some insulators. So you could get a selection of those, give those to the children, let them use them as part of the circuit, or just you yourself demonstrate that with sort of holding that insulating material, making sure that makes contact with one end of the energy stick and you hold onto the other end. And depending upon if it's a conductor or not, that will make a sound, so a buzzing sound, and the energy tube will light. Or if it's not, if it's an insulator, then that will fail to happen. And I just think that's a really effective way for children to understand what's going on and what should be happening before they go to explore circuits themselves, because quite often, if the equipment is used by other people or it's not been used in a while, you having the time to check through that equipment and check it works. And sometimes, misconceptions come about because the experiment doesn't work as it should. So having that demonstration and having that energy stick there to show them is a really good starting point, I think. I think also there is a need to look and think about what's going on in terms of particles. Now, obviously, children can't look at those in particular detail because they can't see inside those wires. So at this point, you have to model. There is no real other option. And I don't see a problem with that so long as you are clear that models are just that. They are a representation of what is going on. So it's not actually what is going on. And obviously models are going to have limitations. And I think so long as you're explaining that and making that explicit, that is going to help to ensure that misconceptions aren't embedded further. So one of the best ways I think to get them involved is, and obviously there aren't any foolproof models, but if you are going to try and demonstrate to children what's happening at the particle level, using a scrunched up piece of paper as a representation for energy, or perhaps using a balloon as well. And I will show some examples of those. So there's some examples of some pictures of children using those and getting involved with sort of setting themselves up so that they're playing a different role. So make sure that you're clear on what the role the children have. So one of them might be playing the role of the battery, one of them might be playing the role of the buzzer, one might just be the bulb or just part of the wire itself. If the child is acting as a battery, that battery provides the push. It's sort of that force which then allows that flow of charge in the first place. So there'll only be one person, most likely, who's playing that role. And then if that scrunched up piece of paper then represents the electron, or if you want to use the term charge, then it's that movement of charge around a circuit that you're going to demonstrate at that point. And the main rule to remember is that they need to pass on their charge to the person on their right or on the left, depending upon which way round you're going and which way round you've got your battery set up. And that's only going to occur when if somebody's playing the role of a switch, for example, once that switch is positioned to on. So that particular model, so if you're using a scrunched up piece of paper or using a balloon, that really helps to address the misconception that the current is a continuous flow of charge, and also that the current does not change actually when it passes through a component. It's still the same. So once it's been through a switch, once it's been through a motor, once it's been through a bulb, that continues. And then, of course, allowing the children themselves. So once you've modeled it, once you've shown it, once you've done your demonstrations, you've explicitly given them the vocabulary, they should then be allowed to explore. And that will be an opportunity for them to understand and to get deeper understanding, and for you to understand what their understanding is. Is it clear? Have they got some misconceptions? And if so, maybe structure some questions around unpicking that and where that's coming from. So at this point, I would be encouraged, or I would be encouraging, the children to get involved with getting some circuits. And I've got some circuits to demonstrate to you in a second. And at this point, obviously with these circuits that you're going to set up, they may not be exactly the same as what I've got, because you might have slightly different equipment. You may have a power pack, you may use a battery. But the idea behind using these circuits is so that they're exploring, they're looking at, particularly in year 6, what voltage is. They might be looking at specific components and naming them and telling you what's happening as you put the switch down and remove. So have that switch as in an off position. But I think the important thing is they're giving you this commentary, or if you're demonstrating to them afterwards, you're giving them that commentary as to what's happening, and you're using that language in the correct way as well. And you're sort of giving time for children to explore and write down any questions. Actually, you might have a box for questions or a board for questions. I think that's really important. And just, your role as a teacher really is just to guide and prompt them, to ask where these questions have come from, maybe what's prompted the questions. So you're understanding as they're constructing it, where these misconceptions might be coming from. And you can try adding extra bulbs as well. You could extend these circuits if the children are understanding and grasping things quite quickly, or you could if they're not exploring different equipment at that point, you might want to get different components involved as well if you've got those available. Okay, so I just wanted to show you some of the circuits that we have in school that are probably similar to what you have in a primary school. And this, I think, obviously demonstrating with a visualizer is brilliant, but just allowing actually the children to become familiar with the equipment is really important, particularly at year 4 level, where they've probably not come across any of this equipment before. So you can see, obviously we've got the battery here, we've got the wires, we've got in this circuit at the moment, we've got your light bulb, and if you wanted to introduce a switch into that circuit, again, you could obviously just get your wires involved and let them play and explore with some of this equipment. So, the switch here is in an off position, and when it's pressed down, and they do have to be held down, you can see there that bulb is lighting, because it's not even as bright, and some of the children might notice that. And you might want to try and address that and explore that, and maybe why that might happen together. So giving them the opportunity to have a look first, and then identifying the components correctly. So we've got buzzers here as well. We've also got motors, and just guiding them and prompting them to think about what is happening in the wire. So right now, what is going on with this battery? It looks like a complete circuit. Why is it that actually that bulb isn't lit? What is going on? Because the metal is in the wire. Those if they're mentioning particles, if they're talking about, they won't be talking and using the word electrons at this point. They might then begin to wonder, well, where if there's a charge going around now, when you're pressing that switch down, how is that happening? Why is that happening? And obviously at year 6 level, that you're getting those questions, you need to give them the time to really explore, if you can, what is going on. So it's that idea of the charge moving around, but obviously when it reaches this switch here, it has nowhere to go. So that requires your switch to be pressed down, and then that flow can continue. And then ask them, prompt them, what is happening in the bulb? Are they using the correct language? Can they explain, if you were to swap that for a buzzer, for example, could they explain what's going on here? And is there a difference? But obviously that depends on what equipment you've got. My buzzer hasn't actually worked with that because I think my wires are too long. But that's another thing you're going to have to, if that happens, children are possibly going to want to know answers. And so you have to think around the subject and be prepared to sort of take those questions and possibly come back to them. But be honest, if you don't have the answers to the questions, absolutely be honest with the children. Just also to show you the kinds of sort of conductors, insulators you might want to use. So we have these in bags, you might do the same. So you've got them to reference really easily. So you've got things, and it's important you're talking about the materials here and not the objects themselves. Because of course some folks that they have at home, they're associating whether they conduct electricity with the item that could lead to misconceptions as well. So we've got a metal here, plastic, we've got wood, we've got foil, we've got cork, we've got all kinds of things. And again, those can be used alongside the energy tube, okay, because those could be used as part of a demo, but also they could be used as part of the circuit as well if they want to investigate, or you have the time for them to investigate conductors and insulators, and you're checking that understanding of those key terms and whether they're using and being used correctly. So I'm hoping that now that you've had the time to watch the video, that's also another reference point to the energy stick there, that you've sort of got some ideas of things that you might want to try. Again, these are referenced in the PDF document. It is available to you, but I'm hoping that it's helped you to address some of the tricky and sort of, because it's an abstract concept, I'm hoping it's allowed you to remind yourselves or revisit some of the practicals that can help children, and obviously some of the key words that could lead to some of these misconceptions. But also I'm hoping that you've now got a bit more confidence, you're a bit more enthusiastic, and the children will be more curious, I think. So feel free to refer back to the suggested resources, and also have a look at some of the further reading that's been mentioned in that troubleshooting document. And thank you for listening, and we do hope you'll consider looking at the other videos in the series as well.